How are you, my friends? In this video, I'm presenting Pre-Calculus course lecture number 7, Exponential Equations. If you want to see other lectures, please, you can go to the playlist down. Now, exponential equation is one in which the variable occurs in the exponent. I put here some guidelines for solving exponential equations. Just before that, I want to mention one-to-one property. If we have a to the power x is equal a to the power y, then x is equal to y. So if the bases are the same, then the powers are the same. Remember always the condition, a should be positive, the base, and a cannot be 1. Now the guidelines, if we have an exponential equation, we can isolate the exponential expression on one side. Then we take log or ln of each side. We use logarithm, the laws of logarithms, and then we solve for the variable, which is x or t or whatever variable in the equation. Let's see example number 1. We need to find x here. 10 to the power x squared plus 6 is equal square root of 10 to the power 10x. We can just see here that we can make the same base 10. So I can play with this square root of 10, which will be 10 to the power half. So 10 to the power x squared plus 6, that's given here. X to the power half, half multiplied by 10x becomes 5x. So we have the same base here. You see 10 and 10. Now I mentioned here, if you cannot make the same base, I will show you in the next example, what do you do? If this is base 10, this is base 3, or this is base 10, this is base 7, then we have to use another method. So we have the same base 10, we use one-to-one property. So this is the same base, we have the same power equals. So x squared plus 6 is equal 5x. Rearrange it. Take everything on one side equal to 0. This is a quadratic equation squared. We can factor it. Now, if we cannot factor it, we can use the quadratic formula. We will see some other examples. So we can factor this as x minus 3, x minus 2. So the solutions will be x will be 3 and 2. So that's the solution set. SS means solution set. Now let's look at example number 2. We have two parts here. E to the power x squared is equal to 200. See, this is exponential. The base here is e, and the base here is 200. We cannot make them the same base. So let me show you now, what do? We take ln on both sides. So we say ln of e to the power x squared is equal ln of 200. Now we can use LE rule, or we can use the properties. So we bring x squared down, ln of e is 1. See, this is 1 here. So x squared will be ln of 200. That's a number here by itself, so we leave it. Now take the square root of both sides. X will be plus or minus the square root of ln of 200. So this is the solutions. Now the second one, you can take a minute to try. E to the power x is equal minus 3. See, here the base is e, and here the base is minus 3. We cannot make the same base, but we can take ln. Now it happened in this one, if we take ln of both sides, we get ln of the negative argument here. ln of minus 3, this is undefined. There is no value. Even if you try this in the calculator, ln of minus 3, the base here is negative, so that will be undefined. So here we can directly say no solution. In this box here, you can see another way to solve this. You can take e to the power x as a function, and then you graph it. See the black one, increasing. You can take this as another function, y equals minus 3, and then you graph it. Y is equal minus 3 horizontal line. See, there is no point of intersection. No point of intersection means no solution, no points in common. Now, more difficult questions in example number 3. We have also two parts. For sure here we have to rearrange it because we have something times something is equal to 3e. So we can rearrange. You see here we have the same base e. Remember in the algebra course, if we have the same base, we can add the power. So add powers on the left. See, this is the rule here. So we add the powers, 2x plus 1 minus 4x. When you add them, you get minus 2x plus 1. 3e, remember here, 3e is not the same as e. So what can we do? Let's divide by e. So when you divide by e, you cancel here e, and here we subtract the powers because we have the same base. So in the division, we subtract the powers. So when you subtract the power here, see that's minus 2x plus 1 minus 1. So it becomes e to the power minus 2x is equal to 3. Now we take ln on both sides. So minus 2x comes down here, ln of e is 1. So minus 2x is equal to ln of 3. We need to find x. Let's divide by minus 2. So here we get minus half. We can write this on the power. See, there's a power law. So we can raise it here, 3 to the power minus half, which is 1 over square root of 3. So x will be ln of 1 over square root of 3. You can take ln on both sides from the beginning here. But see here, I try to simplify the equation first, then I take ln on both sides. Oh, question number 2 now. We have 10 to the power 2x minus 1 plus 5 is equal to 95. We have also to rearrange this. Take 5 on the other side. Now take log on both sides because we have here base 10. We can take also ln if we like. So now we use the laws of logarithms. 2x minus 1, all of it, this is the power, becomes down here. Log of 10, always this is 1. Log 90. So now 2x, you see 2x minus 1 times 1. So I take minus 1 on the other side now, becomes log of 90 plus 1. See the 1, also I can replace it by log of 10. And now I can use the product here. Log of 90 plus log of 10 will be a log of 90 times 10, log of 900, which is 30 squared. So 2x, see, this is the beginning here. 2x is equal, bring the 2 down, 2 times log of 30, divide by 2, so x will be log of 30. Another exponential equation, really very important. This one, 2 to the power x plus 1 is equal to 3 to the power x minus 4. The bases are not the same. We cannot make them the same. But this is ready. We can directly take ln on both sides. See, this is ready. The bases are different completely. So take ln of this is equal to ln of that. Now use the power law. Bring the x plus 1 down here times ln of 2. Bring x minus 4 in the bracket. This is the power here down. Ln of 3. Remember to put the brackets. Now you can deal with ln of 2. You know this is a real number. If you use a calculator, it will be a real number. Ln of 3 also is a real number. So just leave it like this. Leave it there. Just a real number. You can just imagine it as 1.6, 0.9, whatever. So x times this is x times ln of 2, 1 times that ln of 2. So this is a linear equation, you see. X number plus number, x times a number minus another number. So that's a linear equation. Let's continue there. So I mentioned that here, see, this is a linear equation. We need to combine like terms. So I put all the x's together on one side, all the numbers on the other side. So this becomes minus ln of 2 minus 4 ln of 3. Take x as a common factor, as we do in the linear equation. So x will be, divide now by this. So it will be x minus ln of 2 minus 4 ln of 3 divided by ln of 2 minus ln of 3. That's the value for x. Now you can leave it like this. It's perfect. Now, I put here 3 different forms for the answer. You can just play with the answer. See, multiply up by minus, all of it in the numerator, multiply here by minus. You will get the first one here. See, ln of 3 now becomes minus ln of 2. That's one answer. Or you can use the properties. This is ln of 3 over 2, because that's a minus. Bring 4 in the power, 3 to the power 4 times the 2. Also, you can use change of base here. So you can put, this is base 1.5 log of 162. So you can put any form. This is one form. This is 3 different forms. There is a nice idea here. Solve the exponential equation. E to the power 2x minus 3, e to the power x is equal to minus 2. This is different from number 4. You see, number 4, we have one term on one side, another term on another side. If we have more than 2 terms like this, we cannot take ln. So the problem here is we cannot take ln on both sides. Since the equation has more than 2 terms, we have one term, one term, one term, 3 terms. So we can rearrange it, bring the 2 on the other side is equal to 0, and then we can factor. See, you can put here like e to the power x here. You can put it like capital M or capital Y or some other variable. Or you can factor directly e to the power x, e to the power x, and the plus 2 becomes here minus 1 minus 2. So this one is equal to 0, or the other factor is equal to 0. Now we can take ln on both sides. So this is 2 simple equations. It's coming from a big equation here. Now maybe some will ask why we cannot take ln, because if you take ln here, we have something, subtraction. See? So there is no formula for ln of a minus b or a plus b. Even if this is positive, even if this is positive 2 or 5 or 4 or 10 or 9 or 8, you cannot take ln on both sides unless you make the equation simple like this. So now we take the properties here, bring x down, ln of 1. ln of 1 we know is 0. ln of 2 is a number, so we leave it. So the solution set will be 0 and ln of 2. Another one more difficult. See, here we have more than one term, up and down fraction. 10 to the power x minus 10 to the power minus x divided by 10 to the power x plus 10 to the power minus x is equal half. So for sure we have to do here rearranging. Rearranging, you mean cross multiply, simplify, simplify, simplify the equation, then we'll see what can we do. So this equation is not ready at all. See, the other one was ready when we have a number to the power is equal another base to the power. So the first step here is to cross multiply. So I can cross multiply here 2 times 10 to the power x. See, 10 to the power x is like value here, multiply by 2. Minus 2, 10 to the power minus x. 1 times this is that one here. Just to make it easy, you can continue like that. No problem, you can continue. Just to make it easy, I will let 10 to the power x is equal to m. See this one here, I will call it capital M, all of it. This is capital M, so it becomes 2m. See, 2m is easier to deal with. Now, how about 10 to the power minus x? It will be m to the power minus 1. You raise this one to power minus 1, you raise this one to power minus 1. So look at the equation now. 2m minus 2m to the power minus 1 is equal m plus m to the power minus 1. Just rearrange it, combine like terms. See, bring m here. 2m minus m is 1m. Bring this one here, becomes a minus with the minus 2, minus 3. So look at the equation now. M minus 3m to the power minus 1 is equal to 0. This will be 1 over m. Remember the negative exponent. So I can use this one, m to the power minus 1, 1 over m. So the equation becomes m minus 3 over m. See, that's a fraction. So I can multiply both sides by capital M. So it becomes M squared minus 3 is equal to 0. Now take 3 on the other side. We know, remember, capital M is 10 to the power x. So I put here 10 to the power x with this squared becomes 2x. So I can take log now. See, now look at this equation. This is the equation coming from the big equation. So 2x in the power becomes down. A log of 10, we know log of 10 is 1. So 2x will be half log of 3. Just take the this coefficient here, half, on the power. 3 to the power half, square root of 3. So x will be log of square root of 3. For sure, this is base 10. We don't write base 10. Let's find the sum of all the solutions of this equation. Not easy. 9 to the power 2x plus 1 minus 9 to the power x plus half is equal to 2. Now, if you look at the solution of example number 7, we have to remember lecture number 5 in the algebra course. If we multiply exponents with the same base, a to the power m times a to the power n, we add the powers. That's easy. Now let's go back. You see, let's go back. Here we have x plus half. You see, and also we have here 2x plus 1. See, this is addition. This is addition. So I can make 9 to the power 2x times 9 to the power 1. I use this one backward. Also minus 9 to the power x times 9 to the power half. See, I use that one 2 times for the first term and the second term. Now 9 to the power 2x, I can make 9 to the power x all squared. See, this is also in the power. Times 9. So 9 power 1 is 9. 9 to power x, I leave it. 9 to the power half, we know this one is 3. So that's the square root of 9. So 3 times 9 to the power x here, and 9 times 9 to the power x squared. Bring the 2 on this side. Please make sure you understand this. So we have now the equation is transformed into 9 times 9 to the power x all squared minus 3 times 9 to the power x minus 2 is equal to 0. Let w, just to make it easy, you can factor here directly, but let w be 9 to the power x. So 9w squared minus 3w minus 2 is equal to 0. So we factor the equation here. 3w plus 1 times 3w minus 2. So we take the first factor is equal to 0. W will be minus 1/3, or W will be 2 over 3. Now, we know W is 9 to the power x, remember? So I put 9 to the power x is equal minus 1/3. 9 to the power x is equal to 2 over 3. I can take log base 9 on both sides. So here I see, well, after I take log base 9, I see here the argument negative. So there is no value here, not real number. So this is rejected. Now for the second one, we see log base 9 of 9 to the power x is equal to log base 9 of 2 over 3. We bring x down by the laws, and then log base 9 of 9 is 1. So that's the value of the x. Since we have only one value for the x, so the sum will be log base 9 of 2 over 3. So this is lecture number 7, the exponential equations. Now the next lecture will be lecture number 8, which is logarithmic equations. Now you can find all the exams questions at the end of lecture number 8 so that you can practice on exponential and logarithmic equations. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you that this is pre-calculus course, lecture number 7. I wish I can see you in another video with another topic. Thank you very much.